Okay, are we ready? Everybody get their last tweets out? Old. Yeah. Here's. Yeah. I know. I know. I know. I don't know. But you know, when we were growing up, my parents didn't like stuff I was doing, so I get it. I get it. It's just a sign of getting old. All right. Is this where we are? All right. Finally. Yeah. You know what? I missed. Yeah. We're on page 19. All right. So now we are looking at finally getting to equations. We haven't done any solving of equations up to this point. When you solve an equation, your answer is usually like a number, like x equals 2, x equals 5, something like that. So there's a big difference between that and what we were doing before, where we start with an expression and we get our answer as an expression. So how do you distinguish between an expression and an equation? The presence of what? The equal sign. You got to have an equal sign to have an equation to start with. I mean, I know that in my work I kept on saying equals, 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 but in the original expression there was no equals in it. So give an example of a linear equation in one variable. So that means I want to have an equation, so it has to have an equal sign, right? Because I have the word equation in here. I need one variable because it says I need one variable in there, so why don't I use x? And it needs to be linear, which means that the x has to be raised to the first power only. I cannot have x squared in there, x cubed. It can only have x. So anything I can think of that is an equation with x in it, and that's it. So how about this? That's an example of a linear equation in one variable. We have an equation. We have one variable in the problem, x, and it's linear because the power is 1. Anything I can ever think of that has those components to it is called a linear equation in one variable. And so the goal would be, how do you solve for x? Like, how do you, tell me what x makes this true? Can you tell by looking? 3. Because 3 times 3 would be 9. 9 plus 1 would be 10, right? So I can tell by just looking that the answer was 3. Can you tell by looking, I'm going to give you another example below this. Can you tell by looking what the answer is here? Is it a linear equation? I should ask you that. Is that a linear equation in one variable? It's the same variable though, right? X and x. So I do still have one variable in the problem, although it appears multiple times. It's linear because the power on the x is 1. It's an equation because there's an equal sign. But that's a little harder to look at and just say, oh yeah, x is whatever, right? But there should be an x that makes it true, just like the 3 made the first one true. So what we need are a set of steps in order to get to an answer. So what are the key steps in solving a linear equation? Yes, that's the ultimate goal, but we want a process. That's what we can do with equations, right? Whenever you have equations, whatever you do to the left, you have to do to the right. Okay? But when it comes to linear equations in one variable, we like to have a nice little procedure. All right? The first step is to simplify. Yeah, I'll write what I mean by simplify here. Simplify, clear any parentheses We don't have any in the problem I put up there, but if there were, we would want to clear them. We'd want to clear fractions. That means if we have fractions, we want to try and get rid of them. Or if we have decimals, we want to get rid of them. And then combine like terms. Okay, so that's the first step. We simplify. The next step is to isolate the variable. What do we mean by isolate the variable? Get the variable on one side of the equation. Get it by itself. Which side of the equation? Yeah, it doesn't actually matter. You can go left or right. So get variable term by itself on the left or the right. Doesn't matter. Your choice. And then finally, you want to remove coefficient on the x, or on the variable. So in other words, if you have like a 3x, you want it not to be 3x, you want it to just be x, so you have to get rid of the 3. The number in front of the x or the variable is called the coefficient. So I think when I do an example, you'll see how we actually do the removal of the coefficient. So let's do this first one. So let's talk about the steps. Step 1, simplifying. Is there anything I need to do to simplify this? No, there's no parentheses, there's no fractions, there's no decimals, there's no like terms, right? X plus 3 on the left, I can't do anything to that. 7 on the right, can't do anything. So I have already got it simplified. Step 2, isolate the variable. Right now I have an x plus 3 on the left side and a 7 on the right. I need to get that x plus, or the x by itself. So I want to get rid of the plus 3. Plus 3 means you're adding 3 to it. We want to undo the adding. To undo adding, we subtract. So I'm going to write down the equation first. And I'm going to use the vertical method, which means below this, I will subtract 3 and subtract 3. And when you do that, write down what you get. So what's still there on the left side? X. On the right side, 7 minus 3 is 4. Step 2 is done. Step 3, remove the coefficient on the variable. Well, what is the coefficient on the variable? 1. That's actually what we want, right? The coefficient, the number in front of x here is 1. That's the goal. So that's already taken care of. So we are done. We box it. X is 4. And let's check it real quick. If I replace this x with 4, is 4 plus 3 7? Yes. We'll go to the next one. Step 1, simplify. Anything we need to do? What's that? That'll be step 3, because that's the coefficient, right? I'm just going through the steps. Nothing to simplify, right? We already have, there's no parentheses, no decimals, no fractions. So that's good. Do I have to isolate the x variable term? Isn't the x term already by itself? 4x is by itself on the left side, so that's done also. The coefficient removal is step 3, and that's where we need to get rid of the 4. So 4x equals 28. What is the operation between the 4 and the x right there? What's the operation? Multiplication. How do you undo multiplication? You divide. Right? On this problem, we had plus 3. So how did we undo addition? We subtracted. If we have multiplication, we undo it with division. So I'm going to divide both sides here by 4. And the 4 over 4 becomes a 1, right? 4 over 4 is 1. So that's really like a 1x, so I'll just write x. On the right side, 28 divided by 4 is 7. And that's it. And again, we can check the answer. 4 times 7 is 28. These are very basic linear equations here. We're good? Uh-oh. It's a fraction. We like fractions. We don't, right? We love them. So, what are we going to do here? Try and do this without falling. Okay, so how about our step 1? It's done, right? No parentheses, no fractions, no decimals. Step 2, isolating the variable is done. It's already isolated. 3/4 x is by itself. Removing the coefficient, 3/4 x equals 24. The operation between the 3/4 and the x is multiplication. So usually we would undo it with division, right? But since it's a fraction, it's easier to multiply by the reciprocal. So what you're going to do is take both sides of this equation. I'm going to do it below. I'm going to multiply the reciprocal on the left side. And whatever I do to the left side, I must also multiply the right side by the reciprocal. Now, why does the reciprocal work? Yeah, it multiplies out to be a 1. So 1 times x is just going to give us the x. And on the right side, you actually have to do that multiplication. Remember that that's 24 over 1. I believe you can reduce this fraction first, right? Doesn't 3 go into 24? 8 times. And so 8 times 4 is 32. So you should get 32 here. See, these are going to get more complicated. Were there any questions on that? There we go. All right, next one. Step 1. Do we have any combining or any simplifying to do? Yes, the left side, you can put 15x and x together, can't you? That's 16 x's. How about the right side? 24. Step 2, do I need to isolate the x term? It's already done. Third step, clear the coefficient out. Divide both sides by 16. Now the left side just becomes, what does the left side become? Just x, right? So I'm going to continue this over here. The right side, 24 over 16, can be reduced. That's about all we can do to it. So what goes into both 24 and 16? 8 goes into both? So we have what? 3 over 2. All right. All right, now it's starting to get messy. Step 1, is there anything we can do here on the left and right side? Yes, quite a bit of stuff. We can put the negative 8 and 10 together. We can put this 2x together with this x. So let's do that first. I'm doing step 1. 5x and then plus 2 equals how many x's? 3x plus 1. All right, there's nothing else I can do. There's no parentheses, no fractions, no decimals. So the second step is to get the x term by itself. Now the x appears both on the left and the right this time. So you get to choose which side you would like to leave your x at the end. It's not incorrect to go either way. You can do it. So What would you prefer? You want everything to the left? Okay, if we want all the x's on the left, that means we have to get rid of them on the right. How do you get rid of a positive 3x? Minus, right? Why not divide? You want the x to come also? But if I divide this by 3x, won't it go away and just become a 1? The thing is, if I divide this by 3x, I have to divide this by 3x, and this by 3x, and this by 3x, and it's a disaster. So we don't want to divide by 3x, we want to subtract 3x. So minus 3x here, minus 3x here. Start with that. Tell me what I'll have on my next line. 2x plus 2 equals just 1. All right, I still don't have the x by itself because I have a plus 2. So I've subtract 2 on both sides. That way the positive 2 is gone on the left, and all that will remain is the 2x. So 2x equals negative 1. I have isolated my x term. Step 3. Divide out the coefficient. The 2 over 2 becomes a 1, so that just leaves me with an x equals, what's the other side? Minus 1/2. And we'll just leave it as that. Questions? All right. You all seem to be pros at this. So you go ahead and try this one. First step, clear parentheses. Then collect like terms. Then get all your x's on one side. Then clear the coefficient. See if you can follow the process. You already got it? Yep. Seen quite a few different answers, so this ought to be interesting. Thirteen eighths. 13/8. For those of you who finished it, let's vote whether or not you got 13/8. Yes or no? Be honest. No one's going to come and say, ha, you got it wrong. All right, so for those of you who didn't, just make sure you understand, and if you have any questions, let me know on how this worked. I'll run through it real quick. Distributing the 6 through, you get 6x, and then you get minus 12. Distributing a negative sign through here, you get negative and then plus. Then you combine like terms. These two become a 13x. These two become a 5x. Then you want to get all the x's on one side, so subtract 5x here, subtract 5x here. You don't want a negative 12 here, so you add 12, add 12. When you do all, notice I did it all in one step instead of doing 2 separate steps. You should get 8x is 13, then you divide both sides by 8. All right, moving right along. Oh, yeah. So how do we deal with problems that have fractions in them like this? Let's clear the fractions. We don't like fractions. Well, not that we don't like them, we just prefer to not work with them, right? So what we can do whenever we have a fraction is we can always multiply both sides of the equation by any number we want, other than 0. You can't multiply both sides of an equation by 0, because then it just kills everything off and you get 0 equals 0 and it means nothing. So let's look for a number that we should multiply through on both sides. What number should we multiply both sides by? 6, the least common denominator. Now let's see why. We looked at 2, 6, and 2. We're looking for the least common multiple of all of those, which was 6. I'm going to multiply everything by 6. So let's see what the effect has here. I'm going to multiply 6 on the left side. Multiply 6 on the right side, like this. And remember, 6 is really like a 6 over 1, isn't it? I'm only putting that to help remind you of how you're going to multiply this through the parentheses. Here to here, you're really multiplying 6 over 1 times 3 over 2. What's 6 over 1 times 3 over 2? 18 over 2, but that reduces to be a 9. But you still have next to that what? You still have the x, right? So that first multiplication is 9x. What about the next multiplication? Here times here. 6 times 6 over 1, 5 times, you could cancel the 6's, or you could say 30 times 5 is, 6 times 5 is 30. Divide that by 6 and you get 5. So you get the same answer either way. 5 what though? 5x. And then equals, let's do the other side. 6 through here is kind of easy. 6 times 2, 12x. And then 6 times a half, just 3. So plus 3. Any questions on that multiplication? What is the purpose of, yes? Looking for the least common multiple of these numbers. Trying to find a number that's a multiple of all of those. So I could list out all the multiples of 2, all the multiples of 6, and try and find the smallest one they all have in common, which would be just 6 itself. Why do this, though? What's the whole point of this? Yeah, your new equation doesn't have any fractions in it. That's the whole point. Now I go back and continue the step. Collecting like terms, left side is 14x. And now we can solve the rest, right? We get the x's all on one side. What should I do to get the x's on one side? Subtract 12x on both sides. I'll have 2x's equals 3. I've got to move this over here and continue. How do I finish this off? Divide both sides by 2. So what's x? 3 halves, 3 over 2. Questions here? Sure. It's kind of weird. The door just shut on its own there. Anybody have any good ghost stories? Real life ones? No? Sure. I went to a wedding once. Do you want to hear this? I'll tell you a story. Went to this wedding. I didn't know the people. I went with this girl, and she, so I was just there. I was like sitting at this table. It was outside. It was a real nice wedding. It was right around dawn, the sunset. Sorry, and we're sitting outside this house. It's like this old house, and sitting at this table and drinking margaritas. And I look up in the second floor window of this old house, and in the window there's a big curtain, and between the window and the curtain was this little girl. She was like dressed up in had this real fancy little dress on, and she was like standing in the window. I like looked at my friend. I was like, look at that little girl up there. Doesn't she look kind of creepy? Like she's just up there watching everyone. And I figured she's part of the wedding party. She was in this nice little dress. I didn't know anyone there, right? So I was like, she looks kind of weird. Anyway, so she leaves, and later on that night, about, I don't know, half an hour, it's probably about an hour later, the host of the party, right, the people who own the place, went by each table and started handing out flyers. And on the flyers it said, join us for our Halloween, see if you can stay the night in the house thing, where it's basically you register with them, and you and a group of friends go in the house and try and see if you can make it through the night without getting spooked. And I'm like, well, what's this all about? She's like, well, there's a ghost family that lives in the house, and they live on the second floor, and that's why it's closed off. Like, you don't go up on the second floor. And I'm like, what? So I'm like starting to I'm not a big ghost person, so I'm like, come on. So anyways, I went around looking for this little girl at the wedding party all night long. I was going up to little kids I don't even know. I'm like, were you up there? And I could not find the girl who was up there anywhere. It's weird. It's supposed to be spooked. Huh? What? Did I know what? I had no idea. Yeah, I had no idea. I mean, I saw the girl. There's no question in my mind I saw her. Now, was it part of that, or was it actually a girl in the party? I don't know. But everyone at my table. Yeah, everyone. But no one else really cared as much as I did. I was like, I need to convince myself that this girl exists before I leave. No, she was dressed, I couldn't tell. She was dressed like someone would be in a wedding. That's what it looked like to me. I wasn't thinking too much about it. I was just like, they must all be up there changing, to come. It was after the wedding, it was dinner time, like after. So anyway. Yeah, and I went in the house to go up there, and they had like a cage that you close. I guess when you go stay the night, they open it and actually let you go up there. It's a place, I think it's called the Black Swan House or something. There was a bunch of slaves that were killed there, that were murdered. It's here. It's here. I think it's called Black Swan. I could be wrong. I'm pretty sure it has swan in there. I don't remember where it was. Yes. It's well known. I didn't know at the time, but it's well known. So anyway, okay. Back to more fun stuff. Decimals in a linear equation. So here, just like the fractions, we want to clear them. So what is it about decimals that you can do with decimal points to make them move around? You can change decimals to fractions, correct? You could. But there's an easy way to just move. Like if I want to move a decimal point to the right once, what do I multiply by? 10. Right? Like if you have 0.4, let's say. What would happen if I take 0.4 and multiply it by 10? Well, 0.4 is the same as a fraction, like you said, 4/10. That's what 0.4 is, isn't it? So if I take 4/10 and I multiply it by 10, the 10s cancel, I just get 4. So multiplying 0.4 by 10 moves the decimal point to the right once. How do I move a decimal point 2 places to the right? Multiply by 100. How many? 3 places? 1,000. So anytime I want to move decimals, I just multiply by either 10, 100, 1,000. just depending on how many decimals I want to move. So looking at all these decimals, let's count the number of spaces I would need to move to make them nice numbers. This one would have to move what? 2 to become a 7. This one only needs to move once, right? To become 81. This one needs to move twice to become 15, but this one needs to move 1, 2, 3 to become 73,416. So what I need to do is come up with a number to multiply both sides of the equation that will take care of the worst case scenario. The 1,000, right? The 3 spaces. So I have to multiply both sides of the equation by 1,000. So I multiply the left by 1,000. I multiply the right by 1,000. You mean just move them now? Yeah, you could. And I have no. I'm just showing the detail. That's all. What I'm actually doing. I want you to know that you're actually multiplying by a number. You're not just moving them because it's fun to move them, right? You're doing something mathematical here. So multiply this. So let's just move the decimal point over. How many places? 1, 2. It's got to go 3 because we're multiplying by 1,000. So instead of turning into a 7, it's going to be 70. X. And then I say plus, and this one has to move 3. 1, 2, 3. 8,100 equals over here. This 1, 2, and then one more. You're going to get a 150x, and then the last one plus 73,416. Any questions? Pardon? Yes, that moving the decimal points over is the result of multiplying by 1,000. I couldn't do it without the 1,000 being multiplied. So that went here, here, and this one went here and here. At this point, you just move things around, right? You've cleared out the decimals. Isolate your x's, right? There's no combining to do. So, are you feeling like you want to always put x on the left, or do you feel comfortable doing it on the right? What do you want to do? You don't like negative x's. So since you have 70 x's here and 150 x's here, it'd be best to leave it on the right. So subtract 70x on both sides. Well, that's your preference. You should have the same result either way. So that's going to get rid of the x's on the left. That means that means my x's are going to appear on the right. So I don't want the 73,416 here, do I? So I want to subtract it from both sides. Subtract it. It'll go away on the right. How many x's are still there on the right side? 80? 80 x's. And when you take 8,100 and subtract 73,416, you get negative 35160. That's all right. And then divide both sides by 80. Now I would have to try and reduce that. 2 goes into both for sure, because they're both even numbers, right? So you could try that. I'm right here. X is negative 65316. No, Try and reduce it. What goes in there? They both go by 4? So what do you get on top when you divide by 4? And on the bottom we did, what, 20? 4. Yes. What else goes in there? I'm trusting your calculator work here. It's not even close to what the key says, so. Where? 1, 6. Okay. 1, 6, 3, 2, 9. Okay. Divided by, so that's what happened when you did each by 4. Still not close to the answer, but. Well, it wouldn't necessarily be wrong as a decimal. What I'm looking for is this. When I'm grading your test, I'm looking for this work. If you get it to here and then you write a decimal, it's fine. You have the answer. What I don't want is when I grade your work is to see nothing except a decimal answer. No work. You're trying to demonstrate to me, again, that you know the process. Just like the employer wants your piece of paper because they want to know you know how to follow a procedure. Same sort of idea here. All right. So 3 categories of equations. When solving an equation, the final equation will look like one of the following examples. So everything we've done up to this point, we got like x equals 4, x equals 7, or whatever it is. But what if you solve an equation, you're working through it, and at the very end you get a statement that looks like this. Your x's all go away, and all you're left with is negative 4 equals negative 4. What does that mean? That means that it's true, right? I mean, that means that no matter what the x is, the equation is always true. So this means make a note here, there's no variable left. It all canceled out. The variable went away. That means the number of solutions you have are infinitely many. Y'all seen that symbol before? I'm not saying the answer is infinity. I'm saying there's infinitely many answers, all right? How do we say all the numbers work? How do I say every number works? Have y'all ever seen this? There's a couple of ways you can write it. Negative infinity to infinity. Have you ever heard all real numbers? Have you ever seen the double struck R? Any of these work. I'll give you an example of this so you can see what the hell I'm talking about. But you need to know that if you're working through an equation and the variable goes away and what you're left with is something like negative 4 equals negative 4, a true statement, that means any x you ever would have plugged in would have worked, which means that you can take any number, and this is the way we say any number. You either write negative infinity to infinity with a pair of parentheses, means any number on the number line, or you put all real numbers, you just write all real numbers, or you write a double struck capital R, which represents all real numbers. When this happens and you get something like negative 4 equals negative 4, we call it an identity. Now, what if you work through a problem, your variable goes away, but at the statement you have doesn't make any sense. 8 equals -2. What would that mean? You have 0 solutions, no solutions. I'm going to put no solutions. So none of them, 0 of them. I'm not saying that x equals 0 is a solution. I'm just saying there aren't any answers. How do we say nothing? We write this. It's a 0 with a line crossed through it. It's known as the empty set. Military people have been taught that this is the way you write O, I believe, so you don't confuse it with 0. But in mathematics, 0 and O, 0 and this symbol are totally different things. This is the empty set versus this is the number 0. The special name from this is a contradiction. See, your final statement is a contradiction. 8 equals -2? No, it doesn't. You're contradicting yourself. And then what happens whenever you actually get something like x equals 7? The variable is there, right? Variable equals some number. That means you have one solution. What is the actual solution in this problem? So what would the solution here be? The number 7, right? Just 7's your answer. And we call this a conditional equation. Meaning that the equation is true on the condition that the x is 7. If the x is 7, the equation is true. There's a lot of equations here. Holy moly. Is that homework? Okay, I was like, wait a minute. I didn't see the homework. There it is. Well, actually, the homework starts on page 23. So there are a few examples on 22 that we should talk about. All right, let me work through this one quickly, all right? I'm going to first distribute I distributed my 5 through the left side, and I got this. Now what? Get all your x's on one side? Well, as long as the end statement that you have makes sense. Look, subtract 5x here, subtract 5x here. What are you left with? -10x equals -10? I think what you're saying is they're the exact same thing. So yes, you're already there. But I really want to stress how this matches what we just talked about. At the end of this, we get -10 equals -10. Is that true? Yes, that means the solution set is everything. All real numbers. How about the next one? 5x minus 10 equals 5x minus 7. So we subtract 5x on both sides again. -10 equals -7. That's a contradiction, right? And what's the solution set when you have a contradiction? Yes, the empty set. Next one. 10x. I need to distribute a negative through here, which changes the signs of what's inside. Over here on the other side, 7x plus 6x plus 10, distributing my 2 through. I collect like terms on the left side. And what's going to happen? I'm going to get those 13x's to cancel, and I'm going to get negative 4 equals 10. And that's not true, right? These were both contradictions, so empty set again. And the last one will be all real numbers. I'll let you work that yourself. So you should get an identity on that one. Then you have all the homework, right? It's all here. A lot of homework. All right, we are done with the review packet. Yay. Stop 35 minutes. Let's go home. I know. Who takes a summer math class? Yes. Yep. Of course, the one I won't do, right, is the one where there's a typo on this thing. Okay, let me go through it. 3 minus 2 plus 7x, 8x minus x plus 1. You got 3 minus 2 is 1 plus 7x. Here, 7x plus 1. Yeah, it's right. All real numbers. Okay. You see where it was. Okay. You want a little mind release for a second? Okay. Let's see if you've ever seen this before. Oops. Mystical ball. So take out just get a little blank page. You're not going to turn this in or anything. Yes. Oh, no. Okay, so on number, you're talking about number 1 of the first homework, or the first problem on page 23? That's just fine. That's saying solve the equation. Okay, you aren't being asked for solution sets until, well, you know what? Doesn't look like there's anything. You're never asked for it. Yep. Well, no, because if you ever do solve an equation and you get one of those cases, 4 equals 4, you would just put all real numbers. So you wouldn't have an answer like x is 4. Or if you get something like negative 4 equals 10, you would say empty set. It's just giving you ways of dealing with when you don't have solutions or you have infinitely many. That's it. You're done. I don't even know if I can find this thing anymore. It used to be at a place called board.com. I'm probably going to put a virus on my computer or something. Mystical ball. Board.com. I know I've seen it here before. If I can't find it, we're just going to get back into it. I will. That was my next option. Mystical ball. I don't see it there. They probably removed it because it's freaking too many people out. Man, where'd it go? It's sad it's not there. Ah, there it is. Okay, I might need to turn up the speakers so you can hear this. It's only going to be on my laptop. So here's what you do. Everybody, you're going to write down a two-digit number. I'm going to do this also. Any two-digit number. Yep, write it down. So I'll put mine over here. Got it? Okay. Now what you need to do is take the two digits and add them together. So I'm going to do over here 7 plus 2, which is 9. You do yours. Then take that answer and subtract it from your original number. And that will give you whatever number it is that you get. You got your number? Okay. Find your number on this list and look at the symbol next to your number. You got it? Everyone has their symbol? I'll try and zoom this in a little bit. I can't zoom it in. Your number's not on there? It's a negative. Shouldn't be. You subtract the wrong way. Your two-digit number should always be bigger than the two digits added up together. What does 11 add up to be? 11 minus 2 is what? It'll always work, trust me. It'll always work. They just subtracted wrong. That's all. They did the backward subtraction. No. Okay, everyone have their symbol? Okay, so here we go. So, was that your symbol? Yes? Okay, it's now look, we're going to reset it, and all the symbols are going to change. Okay. Let's do it one more time. All right. We'll do one more. Take your four-digit number, or your two-digit number, sorry. Whatever you want. Well, if you want. I'm going to do something different, though. I'm going to do 43. I'm going to add the two together. 4 plus 3 is 7. I'm going to subtract 7 from this. 36. Everyone have their number? Have their symbol? The one to its right? To the right of the number? Okay, I've got it. You ready for your mind to be read? Okay, so many years ago, my sister sent me an email or called me or something. She was all freaking out about this. I found this website. It's like reading my mind, and I'm freaking out. And so you're either a type of person who's like, whoa, this is freaky. Let's close the page. Let's move on. Or you're like, who cares? Or you're like, I wonder how this is working. I can't predict who you are or what type of person you are, but I assure you it's not magic. And it's something, there's something that's happening. Let's see. When you did your numbers, did anybody, when they did their subtraction, get a 9? Anybody get an 18? A 27? 36? Anybody get 15? Shouldn't have got 13. So 85. Oh, yeah, I'm saying after you do the subtraction. Yeah, 72. They're all multiples of 9s. Yeah, on all the multiples of 9, you'll notice that it's the same symbol. So look, I'm going to reset it. You'll notice that star here, star inside the black circle, all the 9s have it. But notice it's mixed up, right? It's also on 66, which isn't a multiple of 9, which makes you think that, okay, it's random. But it's going to be the black star, right? Yeah, now we're reading its mind. But the more profound question would be, why does it work? Right? Why is it working? Like, why is that actually doing that? And that's, again, where you wouldn't care, right? You don't care? Too bad. I'm going to show you. You're supposed to pick a 2-digit number, right? XY. As an example next to this, we picked, I picked what over there? 43? I'll go with 43. I picked 43, right? How can I be sure that no matter what, when I do this little thing over there, I'm always going to get either 9, 18, 27, 36, right? How am I guaranteed that's going to happen? So let me try and explain what's going on. When I write 43, I actually mean 4 10s, right? Plus 3 1s. That's what old school, when you're first learning like place value, the second digit is the number of 10s you have, right? That's right. Now, I'm supposed to do that, and then I'm supposed to subtract from that what? What I get when I add the two together, right? But let's not add them together, because 4 plus 3 we know is 7, but let's just leave them apart. This is 4 plus 3, right? That's 7. What if I subtract right here? So what would happen if I subtract the 3 from the 3? What would happen? It goes away. What happens when I take 4 10s, or you could say 10 4s, right? This means you have 10 sets of 4 sitting there. And I take away from it 1 set of 4s. How many sets of 4s would I have? I have 1 set of 4s. I would have 9 sets of 4, wouldn't I? Plus nothing, which would be 36. Now, I'm only setting you up for this. What does this mean? I have 10 x's plus just y, whatever y is. I'm supposed to add the two together, and then I'm supposed to subtract them, right? When I take the y and I subtract the y, what do I get? Nothing. When I take 10 x's and subtract x, I get what? 9 x's. So when you do this little game, your answer will always be 9 times x, 9 times that first digit. So someone give me their number, their original 2-digit number. 36, then you had 27 when you did it, right? Another one, 55, so 5 times 9, you had 45, right? It's always that first digit times 9, no matter what. So this just gives you an illustration of, like, I don't know. We're just getting our minds off of it. But you know what? I have a headache, so I think we're going to stop. I don't know why. I've been getting a headache right about this time of day. I think it is too much math. I seriously have been talking since 9 a.m. We should do a quiz, though. Do y'all want to do a quiz now, or would you rather have a quiz beginning of class next time that's going to count double? No. You want one now while you're warm? Let's take a vote. We have our little thing. It'll probably be like 2 problems, 3 problems. So we're going to vote. Come on. All right, so press 1 if you want it now. Press 2 if you want it to count double and be on Tuesday. So we have a very, very strong majority that just want to do it now. Okay. Now that still means you're going to have one on Tuesday. It still means you're going to have one on Tuesday. It's not going to count double. Do you want to revote? You're still having one on Tuesday in the beginning, just won't count double. All right, that was me. All right, so please, on the top, make sure you have your name. Make sure you have today's date, which is 6/11/15. And please put 1314 on here, even though I don't necessarily need that. Just the date. I go by quiz dates. All right. Okay, you ready? You're to work by yourself, so you'll need to spread out a little bit more so you're not right on top of each other. Everyone that's facing like that's fine. Just make sure you're all, there you go. So please do your own work. I'm not going to give you any word problems. I'll give you one more, and it'll be from today. It'll just be a multiplying out problem. So problem number 1 and 2, just figure out what those are. Problem number 3, simplify this. Order of operations. Number 4, expand this out. When you're done, turn it in right here, and you may leave. I'll put it back up.